Hello students, this is the class of class 9 actually. We are doing the chapter is matter around us pure. Okay, so I am making this video because I was unable to do the classes yesterday due to some reasons. So I will complete the whole chapter in one video. Okay, so maybe the video is about 45 to 60 minutes. So you should watch the whole video to understand it completely. Okay, let us start. Okay, so we will see different kinds of matter in our surrounding. Actually, we will find out one is our element. Number two is mixture. Number three is solution. A solution can also be classified into three kind of uh, parts. One is your pure solution. Another is your colloid. Another is your suspension. Okay, so these three types of solutions are present in our surrounding. Actually, we will discuss all of them and how to separate the substances from each other. uh, we will also discuss this process. Okay, so at first we will see a solution. A solution can be classified into pure solution. Pure solution means the solute and solvents can't be separated by a filter paper. Okay, filter paper or Wattman filter paper, you cannot separate them. The solute particles or ions or particles are so small. Actually, they will range from 10 to the power minus 7, below 10 to the power minus 7 meter. Okay, so centimeter. Okay, now this is the pure solution. You cannot separate the particles of the solute by any filter paper or by any physical process, but you can separate the solution, the solute and the solvent particles by applying heat also. As an example, let us take a glass of water, which is now let us dissolve sodium chloride in it. If you want to separate the sodium chloride by the filter paper or Wattman filter paper or any kind of filter paper or semi-permeable membrane, will not be able to separate them. But you can separate the sodium chloride by heating. By heating, what will happen? By heating, the solvent will evaporate and the solute particles will remain. That you can do it by the heating. You cannot separate it by any filtration process. Okay, okay, okay. So these are the true solutions or pure solutions. You can say they are the true solutions or the pure solutions. Okay, a solute will a solution is equal to solute plus solvent. Solute particle size is very less, then the solution is pure solution. You can also classify saturated, unsaturated, and supersaturated solutions. Okay, so saturated, unsaturated, and supersaturated. Suppose the solubility of sodium chloride is 10 gram per 1000 ml. Okay, let us take 10 gram of sodium chloride is completely soluble in 1000 ml. If 10 gram is dissolved, then it is called the normal solution or saturated solution. If 8 gram is dissolved, then it is called unsaturated solution. Unsaturated means there is more space or more amount of solute can be dissolved in that solvent. Okay, so unsaturated means the amount of substance that makes the saturated solution. If you dissolve less amount of substance than that, then it will called a unsaturated solution. What is the supersaturated solution? Supersaturated means, let us take 10 gram is maximum 10 gram. Suppose maximum 10 gram is dissolved. What? Sodium chloride. Sodium chloride is dissolved in 1000 ml of solution. Now what happened? If you can dissolve, if I can dissolve more than 10 gram of NaCl in 1000 ml by applying any other factor, that solution can or is known as supersaturated solution. What is supersaturated solution? Let us take a beaker here, and let us take 1000 ml of solution water. Now you add sodium chloride. You added 12 gram of sodium chloride. So what will happen? 10 gram will dissolve and 2 gram remains. But you give heat to the solution, you will find out that the excess 2 gram that was in the precipitated condition, that will also get dissolved in the solution. This is a supersaturated solution. By applying any other means or any kind of factor, such as heat is the factor here, if we give heat and can dissolve the more amount of substance in same amount of solvent by applying any other means, then this kind of solution is called a supersaturated solution. What will happen? When the solution cools down, then the 2 gram of sodium chloride will be precipitated again. So supersaturated solutions are stable in supersaturated solutions can be made in different kind of environment. Then whenever it is cooled down, then the excess amount of solute will get separated and will be precipitated. So 3 kinds of solutions are there. One is the saturated solution, the maximum amount of substance that can be dissolved in a certain amount of solvent. If that amount of substance is dissolved, then it is called the saturated solution. If less amount of substance is dissolved, then it's called the unsaturated solution. By applying any other factor or means, if you can dissolve more than that amount of substance, is known as a supersaturated solution. So these are the 3 kinds of solution. Okay, we have understood pure solution or true solution and these 3 classification. Now what will happen? We will see colloid or colloidal solution. What is colloid? The particle size or the size may be generally 10 to the power minus 4 to 10 to the power minus 7 centimeter. What will happen? As an example, you can say milk, or you can say tea, etc. Colloidal substances, they can be separated by special filter papers or parchment papers or semi-permeable membrane. The solute and the solvent, solute and the solvent can be separated by parchment paper. Parchment paper means the paper which is used for to make the currency notes. Okay, so they can be colloid can be separated by the parchment paper, special kind of filter paper such as Wattman 52, or you can also separate them by semi-permeable membranes. They will not be separated by the normal filter papers, such as the laboratory filter papers you find in your laboratory, or will not be able to separate the colloidal solution. Colloids are generally stable. They will not precipitate. The solute particles will not precipitate. Okay, solute particles will not precipitate. They are stable actually. So colloid is a colloidal particles are in between the particles of true solution and the suspension. They are the particles, the solute particles are larger than the pure solutions and smaller than the suspension solute particles. Okay, in case of suspension, whenever you take some amount of water, mud water, and if you allow it to settle it down for a while, you'll see that a certain amount of precipitate of the mud is taking place under the solution. This is known as the precipitation. But colloid will not act like this. If you place a cup of milk, if you place a cup of milk on your table, after if it is not evaporated, after some time you will see that there is no precipitation there. Okay, so colloidal particles are in between the true solutions and the suspensions. They are in the moderate condition. The size is moderate. That's why they are not precipitated. So colloids are generally stable in nature. In colloid, you can see that, such as milk, if you apply a semi-permeable membrane or a Wattman filter paper, milk will be separated as globulin and water. Globulin is the protein particles, or you can say protein particles. Okay, amino acid, but protein particles. Protein particles plus water, this will produce the milk. Whenever it is a colloidal solution, whenever you want to separate them, you can apply parchment paper or special kind of filter papers or semi-permeable membranes. So you can separate the colloids. Colloids can be classified into two types generally. One is your hydrophilic, another is hydrophobic. Hydrophilic means water loving. This is water repelling. Okay, so these are the hydrophilic and hydrophobic colloids. We will not discuss it here, but there are some important phenomena of the colloids present in your NCERT. Okay, now we see, you can see the Tyndall effect. Tyndall effect is a classical phenomenon. You have seen your LCD TV. Okay, LCD. Okay, what is LCD? LCD is liquid crystal display. What happens? You will see in your LCD TV, not LED. LED means light emitting diode. In case of your LCD TV, whenever you sit in a certain angle, the picture is clear. But whenever you sit in the corner and you want to see the TV, you will find out that the picture is not clear. Actually, you will see black. Okay, so LCD is a liquid crystal display. Actually, what happens? The picture tube that is present in your television, after this there is a screen. Okay, the screen is filled with liquid crystals. These will also act as colloid, and show the Tyndall effect. What is Tyndall effect? You can see, whenever you see some amount of smoke, some amount of smoke in the atmosphere, this will in the if it is a shiny day, okay, a sunny day, you will see that the smoke will appear as blue, because the scattering of light takes place, okay. So in case of LCD, the if you sit in the 90-degree angle, you will find out the picture is clear. But if you sit in the corner and the angle is not 90-degree, you will find out the picture is not clear. Tyndall effect is perfectly seen in the 90-degree angle actually, okay. So Tyndall effect is an effect which is shown by the colloids. How colloids? As an example, smoke is also a colloid, because air plus dust particles, okay. So this is also a colloid, it is also a colloid. So colloid will scatter the light, okay. But if you are sitting in the 90-degree angle, you will be able to view the if you are sitting in the 90-degree angle, then you will be able to see it clearly. But if you are seeing as if you are sitting in the corner, you will not be able to see the Tyndall effect. You can see the smoke of a cigarette. Whenever a smoker smokes in the light, okay, in the sunlight, you will see that the smoke that is coming from the cigarette is blue in nature. Why this happens? This is due to the Tyndall effect. You can see the sky is blue because what happens? The amount of dust particles that are present in the atmosphere will make a aerosol. This is also a colloidal particle, air plus dust particles. The scattering of light takes place and the sky seems to be blue in nature. So you should remember, Tyndall effect is very important actually. It is a special phenomenon of colloids. Okay. So this is the Tyndall effect. After that, we are going to different kinds of colloids, such as emulsion. What is emulsion? Suppose you are taking a test tube, okay. Here is some amount of water is there. If you pour oil in it, the oil particles, oil will be not be dissolved in water. The oil is lighter than the water and it will float, okay. This is the phenomenon you will see in the normal case. But whenever you put the test tube in the centrifuge machine, you will find out this kind of phenomenon. You will see here. Okay, you will see this kind of phenomenon. What is this? This is an emulsion. What is this? This is an emulsion. So emulsion is nothing but when two immiscible liquids, you can see there H2O and oil is there. Whenever two immiscible liquids are mixed with each other by an special mean, okay, or you can apply centrifuge, that this kind of phenomenon is, this kind of solution will appear. This is known as the emulsion. Emulsion means mixture of two non-miscible or immiscible, to non-dissolving liquids or immiscible liquids with each other, okay. So this kind of phenomenon is known as the emulsion, okay. So emulsion can be of two types: oil in water water in oil. Okay, oil in water, water in oil. I am giving you some examples here: paint, butter, etc. So emulsion is a special kind of colloid which will be produced by the mixing of two immiscible liquids with each other. That is known as the oil in water, water in oil. Two kinds of emulsion can be seen. Then we will see suspension. Suspension is what? The particles are so large that they easily get precipitated. So spelling may be wrong. Precipitated, full stop. Example, mud water. You can see whenever you take some amount of water from a river, you will see it is muddy. Okay. Now you allow to set it for 24 hours and you will find out all the muds are precipitated at the bottom of the tank, and you can easily purify the water by filtration process. So suspension is another kind of solution which is unstable in nature. Solute particles get precipitated easily. So this is known as a suspension. So we have understood three types of solutions are there. One is a normal solution or true solution, colloidal solution. We have seen the classification also, Tyndall effect, and the suspension. Okay. Now separation process are there. Some important separation process present in your uh, NCRT. At first, we have to see the mixture. What is mixture? Mixture is if you mix two substances, suppose a component A and B. If you mix component A and B in any kind of ratio, then it will form a mixture. Mixture can be classified into two types. One is homogeneous, another is heterogeneous. Homogeneous and heterogeneous. Homogeneous means the ratio will be same in all the ratio is same in all parts of the mixture. The ratio is different in different portions. Okay, the ratio is different in different portions. So this is a heterogeneous mixture. So mixture, if the ratio is constant, okay, then it can produce compounds. Okay, if it is different kind of ratio, then it will be mixture. Okay, so you should remember this one. So how to separate different kinds of mixture? So one important question is there in your NCRT, that is distillation, or it is known as the steam distillation. So let us see one example here. Okay, let us see it carefully. Okay, so this is the uh, preparation. Okay, this is how steam distillation is done. Okay, so there is a round bottom flask here, and we giving heat here. Okay, there is a mixture in the round bottom flask. It contains orthonitrophenol and paranitrophenol. As we know, orthonitrophenol is more volatile and it has a less boiling point. What will happen? Whenever you give heat at a certain temperature, suppose as 40 degrees centigrade temperature, the orthonitrophenol starts to boil off. Okay, the orthonitrophenol starts to boil off, and it gets out from here by this uh, pipe. Okay, or this capillary, and or glass tube. Okay, so after passing from this here, and this is in the still the in the warm condition, and a flow of cold water is given here, the steam will be condensed. Okay, so so you will find out orthonitrophenol in the pure condition in the conical flask. This is the process of steam distillation. You should remember, this one. This process is only valid to separate two liquids from a mixture if they have a high difference in their boiling point, such as orthonitrophenol and paranitrophenol has more than about 15 to 60, 15 to 20 degrees centigrade difference between their boiling points, so they can be easily separated. So when the evaporation of orthonitrophenol starts, the temperature will be remained constant in at 40 degrees centigrade. So this is the way to separate the mixture of two liquids by the steam distillation process. So steam distillation is a process in which you can separate two liquids having having a moderate difference in their boiling points. Okay, suppose you can see orthonitrophenol and paranitrophenol, we can separate by this process also. Okay, then another separation process is known as your TLC, or thin layer chromatography. Okay, this is not in your NCERT, we are discussing it from elsewhere. Okay, TLC, this is known as the thin layer chromatography. So how to do this? Let us take a paper here. This is known as the chromatography paper. It is made of cellulose and Al2O3 coating. Okay. Now what happens? Let us give a dye here, which is a mixture of 3 dyes, and put it in a beaker and you should add solvent here. So as we add the solvent, you will find out the dye will get separated 1, 2, and 3. This is dye A, this is dye B, this is dye C. So you can see that if I put a mixture of 3 dyes here, this can be separated to A, B, and C with different kinds of distance on the chromatographic paper by due to their polarity. Okay, due to their polarity. What are the factors you should know? This is known as the RF factor, or it is known as the retardation factor. What is retardation factor? Suppose the solvent has rose 10 centimeter, A is 5 centimeter, B is 7 centimeter, and C is 9 centimeter. So retardation factor of A, RFA, will be the amount of distance that the dye rise, that is 5 centimeter, and the amount of distance that is raised by the solvent. So it is 0.5. Retardation factor of B is equals to 7 by 10, that is equal to 0.7. Retardation factor of C is equal to 9 by 10 is equals to 0.9. So what is the significance of retardation factor? You can see higher the retardation factor value, lower is the polarity of the dye. That means the dye will be binded weakly. Higher the retardation factor value, lower is the polarity. That means the dye will be binded weakly. That's why there is a significant amount of rise in case of C, but there is a less amount of rise in case of A and B. So these are the retardation factor. By this process or thin layer chromatography, we can find out or separate the different kinds of dyes or different kinds of compounds present in a certain amount of mixture. So this is our thin layer chromatography. Okay, so I'm not stretching the video actually, because you will lose your interest here. So up to this, I am making this video up to this. Okay, after that we will do the next parts in our next class, that is in our that will be in the offline mode. Okay, I will inform you in the group. Okay, thank you.